Good morning, students. In the last class, we discussed about the numericals of chemical kinetics. In today's class, we will continue with that. Problem number 6.
5.
Yes. Next. The initial concentration of N2O5 in the following first order reaction N2O5 changes to 2NO2 plus of O2 was 1.24 into 10 to the power of minus 2 mole per meter. Okay, at 318 Kelvin. Then the concentration of N2O5 after 16 minutes was 0.20 into 10 power minus 2 mole per meter. Okay. Next, calculate rate constant of the reaction at 318 Kelvin. Okay. Students, in this, the given value is, okay, so the initial concentration of N2O5 in the following first order reaction, N2O5 gets fixed to 2NO2 plus of O2 was 1.24. Initial concentration is how much? 1.24. That is or not value 1.24 into 10 to the power of minus 2 mole per meter. Next, the concentration of N2O5 after 60 minutes was R value they given 0.20 into 10 to the power of minus 2 mole per liter. Again, they given initial concentration at time is equal to 0 here. Okay. Next, after 60 minutes, P2 is equal to 60. Therefore, delta T is equal to 60 minus 0, that is 60 minutes. Therefore, delta T value. Are you taking this? Take it. Okay. T. T value is that. Next, this is the given condition. So students, they told you to calculate K for the reactions. Which type of reaction here? They given first order reaction. Correct? The rate equation or a rate constant equation for a first order reaction is K is equal to 2.303 by T log of or not by half. 2.303 by T log of R by. So here 2.303 by T means T2 minus T1 log of R0 means 1.24 into 10 to the power of minus 2 divided by 0.20 into 10 to the power of minus 2. Correct? So that is 2.303 by 60 log of. So this will get cancelled. This one is 0.062 log of 0.062. Okay, so this 0.06, sorry, that is how much? This one is 6.2. Okay, this one is 6.2. Log 6.2 means we have to see the log table in the vertical column at 62 under 0. Okay, so the value of log is then the log table. Wait, I'll say log of 6.2 is, so 2.303 by 60. Log of 6.2 is 0.7923. Okay. So we will get 0.0304 minute inverse. This is K value. Okay, that is 0.0304 minute inverse. Understand? So this one is the initial concentration of N2O5 in the following first order reaction of N2O5 gives rise to 2NO2 plus of O2 was 1.24, and again you check this to how much? 0.24 at 60 minutes means this is the reaction. So this rate equation is taken based on the respective orders. Instead of first order, if they give zero order reaction means the rate equation is K is equal to R naught minus R divided by 3 2 minus T1. Correct? R naught value is how much? 1.24 into 10 raised to minus 2. R value is 0.20 into 10 raised to minus 2 divided by T2 means 60. This one is. So we will get 1.04 into 10 power minus 2 divided by 60. Okay, then K is equal to 1 divided by 60 means 0.016 into 10 power minus 2 or 0.16 into 10 power minus 3 minute inverse. If it is a zero order reaction, this rate constant equation is based on what? First order and second order. Here they mention first order reaction means we take on this. If they mention zero order means this will be the answer. Okay, so this is the way to calculate rate constant of a reaction. Next one. The first order reaction has reaction rate 1.15 into 10 to the power of minus 3 second inverse. How long will 5 gram of this reactant take to reduce to 3? Okay. So listen, here what we have to calculate means first I'll say this is the first order reaction we said. Again the initial concentration we want, final concentration we want, T we want, K. These are the parameters, correct? So R0 value they given 5 gram because it changes from 5 gram to 3 gram. So final gram means final is 3 gram. Next, we have to calculate time. How long will 5 gram of this reactant takes means time. They given the rate constant or a reaction rate that is 1.15 into 10 to the power of minus 3 second inverse. Okay. So from this, as they mentioned, this is the first order reaction. The equation is K is equal to 2.303 by T log of R0 by R. We want T means this become 2.303 by K log of R0 by R. Okay, we have values here. So just substitute 2.303 by K means 1.15 into 10 to the power of minus 3 into log of 5 divided by 3. Okay. So this one is 2.303 divided by 1.15 into 10 to the power of minus 3 into log of 1.666. Okay. So here how to see log table means log of 16 means here in the horizontal it is 16, in this vertical this is 6 and additional 6. Okay. In the log table, vertical this is 16 under 6. This value plus 6 value. Okay. So the log 1.66 will be 2.303 by 1.15 into 10 to the power of minus 3 into the value 0.220. Okay, so if you multiply 3 into you get 0.44 into 10 power 3. That is 10. 0.44 into 10 power 3 means that is 444 seconds. Because your rate constant is given in what? Second. So that means this is 444 seconds. Understand? Next. Problem 9, right? Okay. Next. Show that in a first order reaction, the time required for completion of 99.9% of, so completion of 99.9% is 10 times the half-life of a reaction. So students, here the given show that in a first order reaction, time required for completion of 99.9% is 10 times of half-life. So that is, we have to prove what? T 99.9 is equal to 10 times of TR. We have to prove that. Okay. So first, they mention what? This is a first order reaction. Correct? So first we will consider T 99.9%. Okay. So here R0 will be 1 gram, then R, after R it completes means initial concentration is R, final R0, final concentration is 99.9% of R0 minus 99.9% of R0. Then that is the R value. Because after some time 99.9% of this reaction will come. Understand? So this is the R value. Assume initially it is 1. Okay. So this one is 0.999. 99.9% means in 1 gram it is 0.999%. 99 divided by 100. So R value is how much? 0.001. Correct? 0.001, that is R value, and R max value is 1. Understand? R max value is 1, R value is 0.001. Or you may take R value as 100, this one is 99.1%, then this become, so result, instead of this R, if you take 100 and this is 99.9, then what you will get? 100 minus 99.9 means 0.1. So whatever the value you take, you get that much answer. Okay, students? So from here, we can consider this one. 99.9% means in 1 gram it is 0.999%. So this is R value, this is R max value, and as we know, this is the first order reaction. Okay, so K is equal to our half-life period. I take for half-life period, TR is equal to 0.693 divided by K. Correct? How this will form? By substituting, so listen, I'll take this equation. K is equal to 2.303 by T log of R divided by R0 divided by R. Correct? So when it will become TR? when it is exactly half. But here we are considering this for how much? 99.9%. So then this becomes 2.303 divided by T 99.9 into log R value is 1. Sorry, R naught value is 1, R value is 0.001. Correct? Then that is 2.303 divided by T 99.9 into log 1 to 3 means 1 divided by 10 to the power minus 3. Correct? So that is equal to 2.303 by T 99.9 log of 10 power 3. Okay, because this 10 raised to minus 3 is there, if it is goes to numerator, this becomes 10 to the power 3. Okay, so students, now if this is in the form of log m to the power n, that means n log m. Okay, that means k is equal to 2.303 divided by T 99.9 3 log 10 to base 10. Log 10 to base 10 means 1. So that become k is equal to 2.303 by T 99.9 into 3 into 1. Therefore, T 99.9 is equal to this one. 3 to 3 is a 9096. 6.909 divided by k. This is equation 1. Okay. We know that T off is equal to 0.693 by k. Correct? Because here for T50, we are considering what here? This R0 divided by R0 by 2. R gets cancelled, we will get 2. 50% means 1 minus 0.5. So left is 0.5. Okay. So by considering that by R0 value, we know already T of is equal to 0.693 by k from the equation of life period. We know. So then divide students T 99.9 divided by T of. T 99.9 is 6.909 divided by k. This one. 0.693 divided by. Correct? Next, T 99.9 by T of is equal to 6.909 into k divided by k into 0.693. This kk gets cancelled. 0.6 is there, here 0.69 is there, here 6.9 is there. Then this is 1, this is 10. Okay, so T 99.9 by T of is equal to 10 times. Therefore, T 99.9 is equal to 10 times of T of hence proved. We have to prove T 99.9 is equal to 10 times of T of, and we proved that. Understand? This is one technique. This is important for 3 marks. That's the first observation technical confusion. Okay, I'll write it completely. What is the relation between time required for the completion of 75% of first order reaction with half-life of a reaction. So students, this is homework for you. So instead of 99.99, you have to take 75. Okay, then you get the relationship in the next class. I'll do. Write down the question and solve by yourself. In the place of 99.9, you have to take 75. Next one is time required to decompose SO2Cl2 to half of its initial concentration is 60 minutes. If the decomposition is a first order reaction, calculate rate constant. Okay, so listen. Time required to decompose SO2Cl2 to half of its initial concentration is 60 minutes. If the decomposition is a first order reaction, calculate rate constant. Here in the question they given the initial value is become to how much? Half of its initial. The final value decomposes upon it gives half of its means it is exactly a half-life period. So here they given here how much? 60 minutes. Okay, so we have to calculate K. They clearly mention it is a first order reaction. The relation between the rate constant and the first order reaction and the half-life period is K is equal to 0.693 divided by TR. We have TR value that is 60. Okay, so that is 0.693 divided by 6 into 10 to the power of minus 1. Correct? So this is 0.1, 6 ones are 6, 6 ones are 6, okay, 33, 6 6 are 36 into 10 to the power of minus 1, that is 0.0116 second minute inverse. This is K value 0.0116. Understand? So this is all about the after period. Only last two problems left. One I will do and one I will give it to you. Next, the rate constants of the reaction. The rate constants of the reaction at 500 Kelvin and 700 Kelvin are 0.02 second inverse and 0.07 second inverse respectively. Calculate value of A and E. Okay, so first to calculate A, you have to take, so here they can mention K2 value and K1. The rate constant of the reaction at 500, that is initial rate, K1, that is 0.02 second inverse. T1 is how much? 500 Kelvin. T2 they given 700 Kelvin and K2 is 0.07 second inverse. Okay, we have to calculate what? A value. So formula for the students, log of K2 by K1 is equal to 2.303. Okay, sorry. A divided by 2.303 or T2 minus T1 divided by T1 T2. Correct? So here R value we know, that is 8.314. This is a universal gas constant value. Substitute here, log of K2 means 0.07, K1 means 0.05, so 0.02. Next, A we don't know. This one is 2.303 into 8.314. This one is T2 means 700 minus 200 divided by 700 into 200. 200, this one is 500. Correct? Next, this one is log, the zeros get cancelled means this one is 3.5. Log 3.5 is equal to A divided by 2.303 into 8.314. Here 200 divided by 3,50,000. This will get cancelled. Correct? So if you multiply the students, you get log 3.5 value means 0.544 is equal to EA divided by 2EA divided by 2.303 into 8.354 into 3,500. That is 6701459. That is 1 Okay, 67015. So then EA is equal to what, student? EA is equal to 67015 into 0.544 divided by 2. So 0.544 divided by 2. That will be EA is equal to 18228 joules per mole. Okay. This one is 18228 joules per mole. Or you might take it as 18.228 kilojoules per mole also. Okay. This one is joules per mole. We got what? EA value. Now we have the relationship K is equal to A into the power of minus EA divided by RT. Correct? So consider at this one 0.02. 0.02 is equal to A e to the power of minus EA means minus 18228 divided by R means 8.314. T initial means how much? 500. Correct? Because we are considering 0.02 means that is at 500 degree. So students here, if you consider this value, you will get A e to the power of 1828 divided by 8.314. This 0.01 so this one is taken as log A into the power of minus 4.3. So if you apply log on both sides, that is log 0.02 is equal to log A plus minus 4.8. Correct? Okay. So this one is log of 0.02 log of 0.02 value is minus 1.692 is equal to log A plus minus 4.3. So log A is equal to 4.3 minus 1.692. You get approximately 4.3. 0.38 minus 1.69. Okay, then we got 2.69. A is equal to anti-log of 2.69. So students, in the anti-log value, we have to check this 2 means that is 10 to the power of 2. We have to see at 0.69. So anti-log of 0.69 is do you have log table? 1.192. So this is 1.192 into 10 to the power of, okay, that is approximately A value is 1.192. The anti-log is 1.192. Understand? This is the way to calculate the A value. But students, in this question they ask this A value, but in the annual examination they only told you to find out EA value. Okay? So next question is, I'll write the question, you solve by yourself, and I'll give hint also. Later. The first order rate constant for the decomposition of ethyl iodide at 600 Kelvin is 1.60 into 10 to the power of minus 5 second inverse. Its energy of activation is 209 kilojoules per mole. Calculate K2. Okay, how to calculate? Listen, you know this log K2 by K1. This is taken as log K2 minus log K1. Then you will get some value. If you do anti-log of K2, you will get K2 value. Okay, this is the hint. You do it yourself. I will say answer in the next class. Okay, this completes the chemical kinetics chapter. So students, in this, among 4 derivation, anyone is important for 3 marks, graphs important for 2 marks, problems and the difference between the order and molecularity, order of a reaction and their example is important for 2 marks. This problem is important for 3 marks. Okay, but the first order reaction rate constant, either by giving rate constant calculating off-life period or by giving off-life period calculating rate constant of a first order reaction, that is of Tf is equal to 0.693 divided by K, that related to that equation. So that problem is important for 2 marks. Okay, so this is all about chemical kinetics. Thank you.